We are going to get started so that we can be respectful of your time. First of all, I'd like to thank you for participating in the very first ever MEBB virtual webinar. So thank you for taking the time today to be with us. This will serve as 1 hour of continuing education credits for you. There's a couple things that you need to pay close attention to. A couple of notices have gone out regarding this. In an effort to uphold the integrity of the CECs issued by MEBB, you will be required to respond to various questions that will appear throughout the webinar. Questions will be randomly displayed on the screen, and the participants will need to submit your response while the question is still visible, and then the responses will be verified for accuracy. If you have any issues, please just reach out to me via email, and we'll try to help you along the way. Also, we would like for this to be as interactive as possible, considering it's virtual. You are able to ask questions, and Julia, our presenter, has been kind enough to agree to answer the questions throughout, and then we will have a Q&A session at the end of the presentation. So at this time, I will introduce our presenter. Julia Lewis has been an application engineer for Kruger for 3 years and is one of the primary contacts for product questions regarding grills, registers, diffusers, and specialty products. In this role, she is responsible for technical and application support, as well as special product requests. Julia received her Bachelor of Science degree in both mechanical engineer and mathematics from South Methodist University. In her free time away from work, Julia enjoys watching movies, reading books, listening to the Beatles, and playing the saxophone. She grew up in Dallas and enjoys taking road trips around Texas. At this time, I would like to welcome Julia Lewis as our presenter on chilled beams. Julia?
Thank you, Ginger. So I'm Julia, and yeah, I've been with Kruger for 3 years, and this is a presentation we have over chilled beams and what we can offer to help. So in this presentation, we will go over basic operating principles of both active and passive chilled beams, why chilled beams are useful, Kruger's specific chilled beams models, and how Kruger can help you with your next chilled beam project. So there are 2 main types of chilled beams, 2 types, active and passive. They both utilize induction air and cool the room air across water coils. And the main difference is passive beams do not have extra ventilation, while active beams have primary air supplied to the unit to have ventilation included. So passive beams are better for spot cooling, and you need something else to have ventilation provided to the space. More on passive beams. Passive beams provide sensible cooling only, so no dehumidification. Once again, there's no ventilation, so these would need to be in conjunction with another form for ventilation. Passive beams are also ineffective with heating because air being cooled is what makes it drop into the space. The air passes over the coils, becomes more dense, and drops down. With hot air, it would just rise and stratify toward the ceiling, and so it's not very effective when you have heating applications. We have
Julia, can I stop you right there and let me launch one of these polls, please?
Okay.
Okay, thank you.
Okay, and we have a little video here. And that shows how the passive beam operates. So the warm induced room air goes to the ceiling and is pulled across the coils, cooling the air and letting it drop into the space below. So you do need some clearance above the unit to allow these to operate properly. And the colder the air, the faster it drops and the more air it pulls, which results in a stack effect. And that means cold air increases in density as it falls. And the taller the shroud or stack, the more air is drawn through the coil, which increases the cooling potential for this beam. This is our ASB active chilled beam. And it works similarly to the passive chill beam, except it has that supply primary air. You can see it coming in from the air handler. And once the air comes in through the duct, it goes through these high velocity nozzles. You can see it go through that. Those are the nozzles, and it induces the room air through the bottom. And it passes the room air across the coils, cooling the air and mixing with that primary air before coming out of the unit and supplying the space. So that mixing allows warm air, or it to be slightly warmer air, tempered air supplied to the room. So the high induction and the mixing of air makes it more comfortable environment below in the occupied zone, because there's not as many drafty conditions and it's a more uniform air distribution temperature across the occupied zone. This is another active beam. It's our ACE unit, and it works similarly to the ASB in the last slide, except this is for exposed ceiling applications. So you can see right off the bat, the discharge from the unit is vertical, and it kind of flattens out to cover your space. You can see it better on this profile view. And when it covers your space, the vertical allows it to flatten out and cover your space in an open ceiling when it doesn't have a surface to travel along. And another thing unique about this beam is it has coils on both sides, the left and the right, instead of just the bottom. So the room air is induced from both sides of the unit instead of the bottom, and the air is still mixed and tempered before being supplied to the space. So why are chilled beams desirable? Why do you want to design with chilled beams? Well, the main attraction for chilled beams is energy efficiency. Water is more efficient than air with transferring thermal loads. Sound is also a benefit because lower NC values. So if you have educational facilities or other spaces that require lower NC, these might be good applications to use chill beams. The tempered air supplied to the room also makes it more comfortable in your occupied zone, less drafty, more uniform air temperature. And these beams are also able to be used with small plenum heights. So if you're working with plenum height restrictions, such as building code restrictions, chill beams could be an advantage. So why are chill beams so energy efficient? Well, instead of doing all of the chilling at the air handler, we're doing some of it at the coil, the water coils. So we're decreasing potential energy losses, such as losing air out of the duct, because ducts are more likely to leak than coils are. And more than that, water density is 800 times that of air. And water heat transfer capacity is 3,500 times that of air on a mass basis. So only 15 to 20% of energy is needed when you're using water instead of air. And the main reason for that is air is highly compressible, which takes a lot more energy to move, and water is not as compressible, so it takes less energy to transfer. So all in all, we're offloading most of the work to the water side, which achieves better energy efficiency with these units. The pie chart on this slide is a good visual representation of how the work is being broken down from air or water. And the primary air delivered to the chill beam unit provides all of the latent cooling and a small portion of sensible cooling. Latent cooling is removing moisture from the air done at the air handler. And in cooling mode, around 70% of the space, sensible cooling is handled by the water coil. The high proportion of water side cooling significantly reduces the size of the air system when compared to cooling with air alone. So you only have to use about 2/3. You only need one part of primary air to supply 3 to 5 parts to the room. So that's what that picture at the top right is showing you. So if you have 100 CFM of primary airflow supplied to the beam, then you can supply 300 to 500 CFM to the entire room because of the entrained air. So you don't have to put in nearly as much air as you're supplying to the space below, because if you supply 100 CFM, you'll still induce 200 to 400 CFM to supply to the space below. So in summary, the better applications to use active beams is if you have any heating, you would want an active beam, and active beams don't require much airflow. However, ceiling heights for active beams, they can't be more than 13 feet above the floor for active beams. Passive beams are good for cooling only, they can't handle heat, and you are required to have separate ventilation. Higher airflow space is better for passive beams, and one plus for passive beams is they have no limitation on ceiling heights. So you can put them way high up, and you can even put them behind perforated ceiling, so you don't have to, they're not visually there, and it will still cool the space because the cool air will make it to the occupied zone. Okay, Kruger chill beams. So now we're going to talk about more of Kruger-specific chilled beam models. The ASB is the most common Kruger model used in North America. This model offers the highest cooling capacity per linear foot, and therefore offers lowest overall system cost of all modular chill beam units for our models. The ABX is designed for smaller spaces such as private offices. And it has 4-way throw, so instead of the traditional 2-way throw out of chill beams you get most of the time, or 1-way, the ABX has 4-way throw. The ABD is a slimline unit for a more discrete appearance, so it only is 12 inches wide, 1 foot wide, but because of that, it has a lower capacity, so more units are required to meet your load requirements for your space. These are more active beams for exposed ceilings. So the ACE unit is the unit we showed in that video earlier that had that vertical discharge that made it good for exposed ceiling applications. And we also have this ABH unit, which is meant to, it can be sidewall mounted really high up, and it can be mounted side by side with each other for a uniform linear look in your space. We also have these 2 units that are better for soffit applications. So the ABH and AHH are mounted in soffits, and you usually see these in like hotel room soffits and those kind of applications. The main difference between these 2 models is the ABH has a booster fan, while the AHH does not have a booster fan. Our passive beams are the APA and the APT. The main difference between these 2 passive models is the APT does not have a shroud, while the APA does. And the benefit of these beams, like I said earlier, is you can completely hide them behind a perforated ceiling. So if you have the APT without a shroud and you don't really like the look of it, you can hide it behind this uniform perforated ceiling and still cool your space. These are also really good for spot cooling. So if you have an area that has excess heat loads and you have coils running already for active beams and you just need a little extra load help in one area, these are good to add in. Our velocity control HVC feature is Kruger specific, and it is included by default on most models. There are 3 positions, and these positions are to increase or decrease throws. So it comes standard with the 3rd position you see with the highest throw. But if you have some sort of layout change or some design change and you need less throw to reduce excess drafts or anything like that, this could be very useful. So here's a video we have. showing our HVC. And this is it without using the HVC. And there's the slot adjustment. So you can push in that slot to reduce the throw on one side of the unit, or both, whatever your needs are. And so if you have a big open office area and you decide, I want to put a closed office or put up walls that weren't there previously, then you can adjust these slots to have a better overall system with your design changes. So you can see with that office built in, there's 2 more walls and shortened throw to reduce the drafts at those walls. Another feature we have is the HAQ quality control. And this feature makes the unit future-proof. So in addition to, if you need additional ventilation, so more people in your room or more loads that weren't originally anticipated when it was originally designed, then this allows you to open an aperture and allow more primary air to dump into the space to provide extra ventilation.
Julia, can I please stop you right there and launch another poll, please?
Mm-hmm.
Okay, thank you.
Okay, so this is a video showing our HAQ in action. So this is our ASB unit, and the HAQ is not being utilized. Then you can see that there's an aperture that can be opened to let the primary air dump into one side of the plenum space of the unit. And the air it throws just like the tempered air, the mixed air that is across the rest of the beam. It just has fresh primary air to add extra ventilation. So same office area, but in this case, they added a meeting room. So you'll have more people, more computers, more load. So if you just want some extra primary air put into the room, you can open up those apertures to allow more. So we also have a couple other options and accessories we can offer for chilled beam. One is our Kiwanda wings we can offer. This is for our ASB unit only, and so our ACE unit is usually used in open ceiling applications, but if the ASB, since it's our most popular unit, if you want to also use this in an exposed ceiling application, we have these wings to offer, and they will improve throw in these applications in the exposed ceiling. We also have a swappable inlet location. So usually if you have your inlet on the left side or the right side, your coil connections are on a certain side, but if for some reason that changes or your coil connections are on the incorrect size, instead of having to order all new beams, you can just take off the plate on one side of the unit and switch the inlet because they have they're mounted the same way to the unit. So you can just flip those and change the inlet location. So that makes it easy for field fixes instead of reordering units. We also can offer a push to close latch, and this allows easier access to the coil in the beam. Our regular rifle locks that are standard on these units can get a bit difficult for one person to change out once they get to longer lengths. So this is a solution we offered to make it easier to get access behind the beams. And another thing we can offer is any sort of special coil connections. If you have special fittings you need or valves, we can accommodate that. So you just need to reach out to us and let us know what you need, and we can make it happen. So how can Kruger help on your next chilled beam projects? We have a selection software called KHIT, and on this selection software you can download it. Anybody can use it and download it from our website, and I can show you where to find that right after. And you can pick your model and put in your design data and see how your beam and design will perform and what capacities it can achieve. And this is what the data page looks like. You'll enter your data on that data page, all your design data, and it'll tell you what your coil capacity is to total capacity, and it'll show you your room layout in a couple different views. So if there aren't any questions on this section, I would like to pull up KHIT and show you how it works a little bit.
Are there any questions? If so, please either raise your hand or you can submit the question in the Q&A section. Okay, hold on just a moment. We do have. Okay, I'm going to take a live call here. Greg Lang.
Hello.
Greg, you
Hello.
are live on the webinar.
2 questions: condensate drains and how many coil connections per beam?
Okay, so we
In other
don't
words-
offer drain pans or drip pans because usually we like to design these where that won't be an issue, and your dew point, it's all about your dew point. So that's something we don't offer. But coil connections, it's 2-pipe for cooling, but if you have heating and cooling, like on an active unit, then it's 4-pipe.
Thank you.
You're welcome.
Okay, Julia, I have 2 questions that I have been submitted. What is the typical primary air and chilled water temperatures supplied to chilled beams?
That's a good question. So typically we see supply air around 60-degree supply air and about 58 inlet water temperature. That's what I usually pick when I'm designing something without given parameters. But usually that's all given, and it's 60, 58.
Okay, thank you. And one more. How are induction coils kept clean or cleaned?
That's a good question. I'm not exactly sure. I know you can get access to clean the unit and to the coils by using the latches, because all the perforated faces can be lowered to get access to those coils and clean them. But I'm not exactly sure about the process to go about cleaning them. I just know you have access to do so.
Is that something that some information we could get to the attendees at a later date?
Yeah, I can look into that.
Great, thank you. Have one more. How does TAB balance these?
I'm not sure about that. I know these can be balanced with like one of those hoods, the channel hoods, but I'm not too familiar with balancing practices.
Okay, so is that, we can look into that a little bit further and get this information to the participants also. A great question. Are there any other questions? Okay. That's it. Thank you.
Okay. So here is our website. I'll show you how to download our selection software. So here's our home website, kruger-hvac.com. And you can just go to software, and K-Hit is right here. And then it has more information about what we can show on this selection software. We have chill beams and displacement on it, and you can just download it right here. And once it's downloaded and opened, you'll get a screen like this. And you can go right up here to product search, chilled beams, active chill beams. We'll go with an active because that's more common. Our most common is the ASB. So we can walk through an example with an ASB. And you just double click and it pulls up more information about the page or about this model. And if you notice on this side, it has a lot more information about this model, like accessories, function, installation, a lot more information. If you're needing any of this dimensions, that's useful too. And down here, you can put in some information. The nozzle type is going to be what the primary air shoots out of, those nozzles. And the different types are just different size nozzles. So usually I start with E because that's the largest nozzle. And you can also click your duct connection, coil length, and effective coil length. So effective coil length is how long the actual coils inside the beam are. So you can go smaller if you want space for the HAQ, for example. And then to enter your cooling data, you can come over here to performance and click cooling design. You can also do heating if you have heating and all those designs to add to your project. So once it's here, you can click design data, and this is where you input all of your design data. You can change the room, width, height, length, your occupied zone. That usually stays pretty much the same. But here's where you enter in most of your information. So for one beam, if you have 75 CFM, and so you can pick supply air, which I said 60 is common. Here, inlet water temperature 58 is pretty common. And usually I see mass flow rate, spec not outlet water temperature, and it's 1 GPM per unit. It's pretty good. So once I enter in that, you can see the design status down here. It tells me the total capacity and it's blue. That means there's no errors, or it says check air velocities. And your total capacity is here for your whole space and coil capacity. And this comes into play if you have more than one beam. So you can design your space and you can flip the unit orientation wise, or you can add more units in the space. So you can have, say we have 3 going across and 2. So you have 6 units in the space, and now it says I'm out of range. So this will tell you if your design doesn't fit for your CFM range. So you can put in CFM for 6 units, multiply it by 6, multiply that by 6. These two can stay the same, and you still, so now you have a space with 6 beams, more CFM, and down here, you can also change your terminal velocity. So this can be super useful if you want to know the velocity of when your collision points hit your occupied zone. So if you click OK, it'll actually show you an asymmetric view of your space, which is nice to see. You can see where all the collision points are and where it hits your wall, how big your room is, and all of the data up here. It'll give you NC, any values like that you need. Down here, this is the useful velocities at your occupied zone. So you can see V1 here and V3 here, and V1 is here and V3 is here, and you can see that that's the velocity when it hits that point. It's kind of hard to see, but there's like a dotted line here, and that represents your occupied zone. So you could also change the view might be easier to see on this view. And so you can see V1 and V3 more clearly here, and your occupied zone. So this tells you what your velocity is when it gets into the occupied zone. And yeah, is there any questions about the our selection software? Anything else you want to see done?
Julia, we do have a couple of questions here. The first one, is the CFM you are referring to the primary air only?
Yes. Yes, it's not considering all your induced air. So like that equation from the PowerPoint, you can induce 2 to 4 parts more than you're supplying to these units. So the capacity that and what you're supplying to the actual space is a lot different CFM wise.
Okay, thank you. Another question, what is the minimum primary inlet airflow rate on a typical active chilled beam? Is it good design practice to set the minimum primary inlet airflow rate to the ASHRAE 62.1 minimum requirements, or does the chilled beam inherent dressing require higher airflow rates, thus not leading itself to variable flow operation?
Okay. Well, the nice thing about this is if your airflow rate is too low, it'll tell you down here. So if I put in a different CFM that's too low, so this program already has a minimum amount of airflow, primary airflow to supply and it to perform properly. So if you stay in between this range, so this is saying you have to be at least 318 CFM to 648 CFM to have these units function properly.
Okay, thank you. We have a couple more questions, if that's okay. We'll just keep answering. During the initial startup, how should the humidity of the space be dealt with to keep them from raining?
Okay, so that all depends on your dew point and where you are and what your how the conditions about where you are, how the conditions are. So if your dew point is too high, then the only way to really reduce the chance of it raining or dripping is to reduce your supply air temperature. So, or increase your supply air temperature, sorry. If you reduce it too much, then it's more likely to, you have to find that point where your environment can handle your supply air temperature without causing the dripping. So you would need to increase your supply air temperature.
Okay, thank you. We have another question here. Is the return water temperature indicated in the calculation table?
I do not believe so. Let's see. Oh, change that back. It does give you the dew point temperature of when it should predict when it will start dripping. Let's see. Outlet water temperature. So yes, it does predict an estimate for what your outlet water temperature will be right in this table. And you can add this to your project. There's a button down here that says add to project. And you can keep adding more configurations with your different design and add them to your, you can see them in engineering view. You can have your whole job of beams with all the different requirements shown here. And then you can go back to the ASB. There we go. Okay, so this is back up. But yeah, so you can see the outlet water temperature here, same with the dew point.
Okay, thank you. Next question, can you mix active and passive in a room with a selection program?
You cannot. You can only use one model, one type in the selection program, and you can't pick what pattern you put them in specifically. So if you saw it when I had 6 units in here, it picked where to put them. You can only pick rows, columns, and you can only do one model at a time.
Okay, thank you. One more question. Can these be used with variable airflow applications?
I believe so. VAV, I assume with the terminal units and adjusting airflow for turn down or things like that, they can have a range of supply air sent to them, and they will perform well. With lower air, there's a range that it can work in. So as long as it's in that range, then yes, you can have a lower air and then have higher air when there's more people in the room and more loads to satisfy.
Okay. We don't have any questions right now, but I am going to launch another poll.
Mm-hmm.
Okay. Thank you.
And another thing about this program is it can show you if your nozzle type is the wrong size as well. So if you have a nozzle that's too small for your primary air, it'll tell you this nozzle can't be used with that CFM range, and it'll let you know that you need a larger nozzle type. And they all have their own range that they are able to function in. So the E nozzle is usually good to start with, and you can just go down until you have the nozzle size for your CFM rate. And you can also see dimensions of nozzles and coil connections. Any of that information you need can be given here. Is there any other beams you'd like to see? Maybe a passive beam?
I think that would be great. We have about 15, 20 more minutes, so.
Okay. So here's your width for these units. You can actually select which width you want and number of water loops.
Julia, I have a question.
Mm-hmm.
Is it good practice to use 2 chilled water loops, one for AHU, etc., and one for beams?
It doesn't really matter as long as the air temperature going into the beam is what you need for the capacity you want. We can provide any sort of connection you need for any pipes that are set up.
Okay, thank you.
So this one has more locations because of the throw options on it. So it's not just the two-way throw the ASBs have. So you're able to pick more orientations where they start. See, now they're opposite on opposite side of the room, and you'll have your collision point in the middle. And that obviously is not how you're going to want it to look, but it's the same sort of design that you input here. But the ASB is definitely the one you have to, these units, you enter in the most information. So if you know how to enter in information on this model, you'll be able to, all the other models require less information. So yeah, it's erroring out because of the nozzle type again and the size reset, but that's because I closed out of it. So it flips it that way, or yeah, any way you want it to flip really. And yeah, is there anything on the slides that we could go over anymore? For more questions, I know there's quite a few more of the pop questions to go through.
I am going to, okay, I'm going to launch one more poll. If you have any questions for Julia, now would be the time to either raise your hand and we will unmute you, or submit your question via the Q&A section of the platform here. I'm launching the next poll. Are there any questions for Julia at this time? Julia, I wanted to go back for just a moment to the couple of questions that you're going to get some information back to us. The question about the cleaning, and then also the balancing question. If you, I don't know what would be, I guess you can just email me that information and then I can distribute that to the attendees.
Yes, I can do that.
Okay, perfect. We have a couple more questions. Do you recommend active control of the CHW by monitoring dew point in the space served?
Okay, so that's for the coils, I assume. Monitoring always can help if you are able to keep track and know what you're supplying. I think it can't hurt, it always helps, but
okay. The next question, are chilled beams used primarily in dry? Well, the question went away, sorry. Hold on, sorry. Are chilled beams used primarily in dry climates where humidity isn't an issue?
Yes, these are definitely better in more controlled humidity kind of environments. These are actually pretty common in Europe, where they don't have as much traditional air or overhead air distribution. They've leaned heavily on the chilled beam in this process, it's a bit more new to North America. So it's not being designed as much in spaces here, and a lot of humid places are definitely shying away from it more because of the dew point being hard to, it's hard to not have them drip.
Okay, thank you. I am going to launch the last poll. And then we do have another question that just, actually I have a couple more questions that we'll ask here in just a moment. Okay, thank you. The question, did I understand correctly? Chilled beams are not good for dehumidification. On new construction, should alternative dehume systems be planned for during the initial startup?
Yes, especially for passive beams. They provide sensible cooling only, so no dehumidification. You'd need some other way to ventilate the space and dehumidify the space. So that's particularly the case for passive chill beams.
Okay, thank you. Are there any other questions? Okay. Well, I think that concludes the presentation. Julia, thank you so much for joining us and providing this. And we look forward to the additional information that you'll be providing us, and hopefully having either yourself or someone from Kruger that can actually join us live, fingers crossed, next year at our recertification seminar. So thank you again for your time. We appreciate it. And to all the participants, thank you for your time today. We will be getting these CEC credits, certificates to you as quickly as possible. Please don't forget about the webinar we have scheduled for tomorrow, Tab and Clean Room, Bridging the Gap by Patrick Law. It will be again at 12 p.m. Eastern Standard Time. So look forward to seeing those of you who will be participating in that. So thank you very much and have a great oh, wait a minute, one more question. Oh, no, someone just thanking us. Okay. All right. Thank you so much. Have a great day.